with differentiation rules. So in other words, we are making our life easier. We are going to look at different rules and not have to find f prime using the definition. So some of you got a little bit of points off, and rightfully so, if you did not write the limit operator in front. So if you determined f prime and I did not see the definition, you did get a couple of points off. Okay, here's why. This function consists of two major concepts, not one, but two. One major concept is the difference quotient, and the other major concept is the limit. If you leave any of these two out, then you are not determining f prime. You're determining something else. Okay? So what are the differentiation rules? Well, the differentiation rules move away. They move us away from this definition. So they make our life easier. So let's start with the easiest one, I would say. The most important, maybe just the first one, power rule. And the power rule states the following, that if I have x, just plain x, to the nth power prime, it's this, right? All we have to do is bring down the power, subtract 1 from the power, and to be honest, and I'm going to put it in a different color, to be honest, I should write times this piece prime. Why don't I write this piece prime? Can anyone tell us what does x prime equal to? In other words, for a function f of x equals x, what is its slope?
One.
Exactly 1. That's why x prime, which is the slope of x, is 1. That's why we leave this out. The reason why I'm talking about it right now, you can say, but what's the point? It's 1. You will see why I'm talking about it. I will come back to this idea and I'll tell you why I'm talking about it. Because this formula is not really complete unless I write this. But at the same time, I don't need to write it because it's 1. Okay. Now what happens if I have a constant in front? Let's say 5x to the third, and I want to differentiate. This will take me 5 minutes to plug this function in here. Plug x plus h in x cubed, factor all 5, put it in front, and so on and so forth. It would have taken me a few minutes. But we have the power rule on x. So exactly the same steps. I bring down 3, but this time I have to multiply it by 5, subtract 1 from the power, and then just think, okay, x prime, what is it? It's 1. I'm not going to write it. Can anyone give us the answer here?
15x squared.
That's it. Again, what is this? What am I talking about? Again, let me make sure that we understand. If a function is given to us as 5x cubed, and we are asked to find a function that gives or determines the slope or the rate of change at all points where 5x cubed, I know it's a long explanation, where 5x cubed is differentiable, then I find f prime. So find a function that gives the rate of change at any point, at all points where 5x cubed is differentiable. I am really asked to find f prime of x, which you already gave me, is 15x squared. And if our boss, let's say, I'm going to say that this is 5x cubed. If he or she says, well, determine the rate of change when x is 5, which is the slope of this tangent, I'm not going to measure. No. I'm asked to find, so the slope at 5 is, the slope of the tangent at 5 is f prime of 5. And I'm going to say it's 15 times 25. So if this is the profit function, I will say to our boss, at 5, the profit is increasing, and the rate of change at this point is whatever this is in dollars per day or per month or whatever it is, but it has to have 2 measurement units. It's the slope. It's rise over run, so it has to have 2 measurement units. So that's the idea. That's why we are always trying to find the rate of change of a function. So see what the function is doing. Maybe a function is increasing or decreasing or has a max or has a min. We're going to talk about all that in chapter 4. Right now, we are going to focus on how do we find derivatives fast, not with a definition. This is done. We got it. We know how to find them. It would be difficult for all functions, but we know what the definition means, and we know how to find them if we can with the limit. But we want to move away from that. We want to find rules so we can find the derivative or the rate of change where the function is differentiable fast. Okay, enough of that. So now let's look at, stop me anytime, right? Okay. So let's say we have a function plus another function and we want to differentiate. Or let's say they're subtracted. How do I differentiate a sum or a difference of functions that are differentiable, of course? How do I find this? It's very similar to limit of f plus g as x approaches a. What was this equal to? Assuming the limit of f is a number and the limit of g is a number. What did we write?
The limit of f plus the limit of g.
That's it. So this is very similar. Besides, they're both limits. This is a limit of the difference quotient, and this is the limit of a difference quotient for a different function, right? F prime. So this is f prime plus or minus g prime. So let's look at one very important rule. So I'd like to discuss 1 over x prime. Very important, and I hope you're going to carve this in your brain. And I want to discuss this. So the derivative of 1 over x and the derivative of the square root of x. Okay, so 1 over x, is there another way of writing 1 over x?
X to the negative 1.
Very good. So x to negative 1 prime, I'm applying the power rule. Negative 1 goes in front, times x to which power?
Negative 2.
Very good. In my mind, I should write this. But there is no need. Why? Because x prime is 1 1. So this is definitely -1 over x squared. So please carve this in stone forever, please. Same way here. Is there another way of writing the square root of x?
X to the 1/2.
That's it. So when I differentiate, same property, same rule, power rule, bring down 1/2, and x to which power?
-1/2.
-1/2, which results into 1 over 2, the square root of x. To be carved in stone. Yes, I should write, but I don't, because it's 1. Carved in stone, please. Very important. You will see in the next sections why I insist on reminding you this. Actually, I make my life easier. Okay. One other thing I would like to mention here, e to the x prime. E to the x prime is very nice. E to the x. So 3 very important functions and their derivatives. So I'm opening it up for discussion here. I have the book. I thought I did. Yes, I'm here. Yes, yes, yes. Yes, I'm here. So they're talking about some maintenance, just to remember tomorrow, whatever they're saying here. Okay, so I would like us to differentiate the function. So we have anything from 3 till, my goodness, till, and then we'll talk about something here, till 40. So I'm going to go back slowly, and you choose. Let me talk about this notation before we do that. So when we talk about f prime, we know that this is the derivative function of f of x. If you want to insert here, there is no need, but you can say the first derivative function of f of x. But what about the notation dy over dx? It means the same thing. Sometimes we prefer this, sometimes we prefer this. This notation has a name, Leibniz notation. It bears the name of the person who invented it. So what does this say? That we are differentiating a function which now is denoted by y with respect to, we are differentiating it with respect to x. So if I don't say anything, I don't show you the function, and I'm asking you, what does dp, let's say, over dt mean? You will have to say, first of all, this is a derivative of p of t with respect to t. So we are differentiating function p with respect to a variable t, which means automatically that p is a function of t. Otherwise, I wouldn't be able to differentiate. So p is not function of x, is not function of y or w, but it's a function of t. So this notation automatically says that this is a derivative Secondly, it tells me that there is a function p that has t in it, and it's the only variable. Okay? So they mean the same thing. Later on, we're going to discuss this notation again in chapter 4. Okay. So when it says find dy over dx or dy over dt, it means that y is a function of x, and we want to differentiate it. Here it means that y is a function of t, and we want to differentiate it. So please choose anything you like to work on, any function. If not, I will choose. I really want to choose 13, and then I'll let you choose the next one. So s of t equals 1 over t plus 1 over t squared. And then feel free to choose the next one. So here we're asked to find s prime of t. Remember, I always try to make my life easier. There is no need to change this because I already know I carved it in stone. Every time I'm asked to differentiate 1 over t, I immediately write this blindly. I don't even think. But this one is different. So I will change the function into 1 over t, but plus t raised to -2. Because this is easier now to differentiate than this. For this one, I will never make any change because I already know this prime is this, carved in stone. But now, can we differentiate this piece and tell me what to write? Anyone? No one wants to differentiate t to -2?
-2t minus, or to t to the -3.
Excellent. So -1 over t squared minus 2 over t to the third. Normally, if we do something else with this, I would say find the least common denominator and add these fractions because they're both negative, so I'm going to add them anyway, right? But right now, it can stay as is. We're practicing. Okay, anything else here that you want to work on before we look at some word problems? And I also want to look at